Good morning, guys. Sorry about the delay in getting this made. Being a mother is wonderful, and sometimes you don't realize you don't have enough time to do things. Okay, so we left off in 7-3 notes, and we had done examples 1 and 2. No, well, 1 and 3, technically. We also did one with that we added to the notes as well. But now we're going to talk about example number 4. I want you to notice the differences between example number 3 and number 4 in the sense that this one, 7 pi 12ths, we're able to separate that into parts that we know on the unit circle. When we're going to do 9 over 41 and 7 over 25, it's really not possible to find values on the unit circle that we know that's going to give us those. So we're going to have to do something else. So first thing we're going to do, and this is a big hint that I give you always, is that I give you the quadrants. Now 0 to pi halves we know is just the first quadrant. We're going to start slow. Someday you'll have other quadrants to work with as well. So what I'm going to do is draw triangles in the first quadrant. And I'm going to label one triangle X and one triangle Y because we have two different variables. Then I'm going to label my triangles. Alright, I've labeled my triangles and drawn them, and now I'm going to solve them. This one is going to be 40, nice Pythagorean triple there, and this one will be 24. Now it's possible for me to know and find the values for the sine and the cosine for each angle. The reason why that's good is I already have written down the identity that I'm going to use here, the differences of the sine. And so I can fill in with the values that I know. I did this up above so that I had a little bit more room to play around with stuff. But I already was given the sine of x was 9 over 41. Now, however, I know that the cosine of y, make sure you're referring to the correct triangle, triangle y, the cosine is 24 over 25. Then I know that the cosine of x, which I was not given, so I have to find that as well, and I'll do that in blue. I'm doing the ones that I had to find in blue, was 40 over 41, and I was given the sine of, move this over, sine of y, that was 7 over 25. From here, this is a basic multiplication, algebra problem, etc., so I'm going to stop the recording and simplify it quickly. Alright, so as I simplify this, I'm going to multiply straight across. So 9 times 24 is 216 over the common denominator. I'll find that in a minute. Minus 40 times 7 is 280. And then 41 times 25. They both have the combinator of 10, 20. I think I said the combinator. The common denominator. And when you do this, because you're combining sine of x and cosine of y and then cosine of x and sine of y, because their values are intermixed, they are going to have the same common denominator set up for you right away. So when we subtract them, we're going to get negative 64 over 1025. And if you can simplify that, go ahead and do it. I'm pretty sure that doesn't simplify. It does not. One question kids always ask me, but I can't do this without my calculator. You're absolutely correct. You can find the triangle and solve the triangle for the most part without your calculator, but that multiplication or anything, I mean, I suppose you could, but I'm not going to make you do it without your calculator, and so that would definitely be on a calculator portion of a test. So let me know if you have any questions. I would like you on Monday when I'm gone, because I'm out. You need to do the try these. You need to work on those, and I will be telling the substitute that you need to do those. There's one of each kind of problem, so you're going to figure out what adds to 75 that you could use. Hint, hint, nudge, nudge. It's very similar to a cosine of 15. And then you're going to do example 2, which is just like the example we did. Draw your triangles. I was still nice to you. They're in the first quadrants. Label them, etc., etc. And then number 3. It's supposed to be in the box, and I believe for you guys it is. It's just not when you upload it to the program to do this. It kind of gets the spacing funky. I would like you to verify secant of pi plus a is equal to negative secant of a. It's in this section for a reason. You're going to use a sums or differences identity to be able to solve that. So that's my hint for you on number 3. When I come back, we'll start section 7.4. My expectation is that you guys will be working on your homework, especially 7.2. Some people are already finding really good ways to work through that extra credit problem on 7.2, so good job. Remember, extra credit is divvied out based on how many I get back. Okay, see you guys. Bye.